So I will be talking about things that we have next in the queue, kind of as an update to a similar presentation given by Andreas at the last LAG. So as you all know, the 2.4 release have been released already. That includes some parts of DNE functionality, which is a distributed namespace that allows you to have multiple metadata servers in a limited fashion. So the DNE phase 2, which is also an ongoing OpenSFS funded project, further improves this to allow you all sorts of other cool things. Like now you would be able to actually move inodes between different metadata servers, which is not possible right now, but is desired for purposes like MDT load balancing and stuff like this. This is not atomic right now, but it's still better than what we have in the 2.4 release. The other thing is the asynchronous remote updates that do away with the synchronous updates on MDTs when you actually do cross-MDT operations. Those are replaced with commit and share for distributed updates, and so kind of better performance when there is no conflicts. This should also allow for safe rename and safe linking cross MDTs, which are unsupported operations right now. And last but not least, it will include striped directories, which is a big desired feature where, like right now, you are able to only have a single directory to reside on a single MDT, and with this featuring, you will actually be able to share those large directories that many of you probably have across multiple MDTs, so you can actually get a speed boost even on those ones, and are no longer constrained by single MDT performance. The Lustre file system check phase 2 and 3, meaning that phase 1 is already into 4, becoming more and more DNE aware. So there are all sorts of other cool consistency checks going in for all sorts of interesting breakage cases, and especially the interesting breakage cases that are becoming possible after the DNE got landed. So all those interesting cases are going to be handled, like the cross-consistency between different MDT trees, where you will be able to see, where it will be able to see the lost subtrees, recover them, link them in wherever needed. The consistency check and repair between MDT and OSTs would become possible, so the missing and lost objects could be identified, objects that think they are attached to a wrong file, or names on MDTs that think they point to a right object, but in fact they should be pointing at something else. All these interesting cases will be handled by the file system checker, and so this becomes a better and better thing, and the best of all, no longer need to bring the entire system offline when you actually need to check for those things. Not that you should be having those problems in the first place, but this is the software. Yet another project that was funded by OpenSFS, the design at least, is the client-IO simplification. So the client-IO code originally was thought as this great project to improve Lustre client-IO stack that was our legacy and not really having the features desired for various cool things like replication and stuff. One of the design goals for this client-IO rewrite of old was to actually make it simpler and more maintainable, but unfortunately there was a bug in that design, and so it became overcomplicated. So now we are ongoing for a project where we will actually make it simpler. We will reduce some layers that we believe are extra, like there is extra caching for locks going on in there that totally duplicates lock caching by LDLM. So that's one of the things we hope to do away with. Additionally, there are tons of crafts still accumulated from the years past, like OBD operations that are no longer used by almost anything. There are other things like LOV structures that are used all across the very top level, like LAD. We plan to do away with those as well. By removing all those pieces, we totally hope CLIO will become even more simpler, but hopefully not any more buggy than it is now. But being simpler also hopefully means more understanding of how it works between developers too, so that it's also easier to continue to fix it, and it's still a quite new piece of code, even so it was introduced in 2.0. The other thing is we plan to streamline I/O call paths in the client I/O for better performance. Like currently, most of the I/O still goes into Lustre one page at a time, which is really CPU consuming. So by doing away with that and submitting multiple page chunks should really improve that. Fujitsu is continuing to provide us with features from their FEFS development to be included into our new releases. The next batch is going to include things focused on memory management, the procfs statistics that will be optional per subsystem. So, for example, when you have a client with tons of OSCs because you have many OSTs, you will have a choice not to allocate any of the large statistic data for those OSCs and save quite a bit of your client memory. The other similar feature is OSC request pool aggregation, where right now each OSC has a special pool of pages just in case we are low on memory, so that we can actually still send requests and free memory by flushing dirty data. When you have just like 10 OSTs in your system, or even 100, that's not such a concern. But when it starts to approach thousands, those 10 buffers per OSC really does add up. So this particular feature will aggregate those pools into a single one from which every OSC would be able to draw their requests. And in general, that would reduce the amount of memory reserved for the system on the clients. Upcode time execution histogram will allow you to see how long does it take to execute different operations on the server over time, which is right now we just have this snapshot like, oh yeah, we executed a little bit of stuff since last you checked. So it should be useful. And a big rewrite they're hoping to include is the open replay handling rewrite. Right now, and this both goes for memory reduction and also interoperability help. Right now, when there is when you open a file or have otherwise uncommitted operations, we store those requests on a client in a list just in case the server goes down and we would need to replay those. And those requests are stored verbatim too. So if a server that comes up is a different version, the server actually needs to know how to speak those old RPCs, how to understand the old replies too. This work will just store like list of open handles, which we already do anyway in the kernel. And if a need arises to replay any of that, a special code will just reconstruct the requests as they were in the protocol version that the server can actually understand. Very similar to how we currently replay LDLM logs, where we don't actually store LDLM requests, but we store the logs themselves, and when it comes time for reply, we just iterate the list of logs and generate the new log requests. So doing similar stuff for open replay, we believe, should help quite a bit with this area. Shared key cryptography. It was touched about by Indiana University, and it's a pretty important topic, I guess, but I'm not going to talk too much about it because we heard from them already and some things have changed since the slide have been produced. Okay. The UID mapping is another feature from them that's also very important. Will allow us to map multiple client clusters on your servers with authentications if necessary and so on, with mapping for the UIDs and GIDs on OSTs to allow quota to work and so on. And we have heard about this yesterday as well. T10 P or T10 diff data integrity, which is a SCSI data integrity protocol, will be provided to us by Xyratex eventually. Actually, they did provide it, right? But it's still waiting in the queue for a new feature window to open. Will allow data integrity from syscall to disk, which is great. And apparently there are already some changes from this slide on how it's going to look. But the important part is we will have more data integrity for those who actually have the hardware that can take advantage of this feature. File replication is another one of those. We really must have this feature, since this will allow us to actually replicate file data on Lustre servers without having a requirement like right now where every storage is, if you really care about redundancy, your storage must be redundant and it should be multi-headed so that like if your server dies, another server can pick up. This should allow for more commodity storage to be used so that every file, or at least the files that you would like to replicate, would have a copy on several targets and just bound together by a layout. The phase one of this work is just read-only replicas, where you write your file, there's only one copy, and then a special offline process will kick off. It will copy the file into another one and then use an I/O control like file join to let the system know that, hey, look, there's actually more than one copy of this file. This will bring us already multiple benefits, like the highly contented files, you will still be able to read them from multiple clients quite fast, especially if you're like booting from Lustre and you are reading the same file over and over again and overwhelming the server that it happens to reside on. This would allow you to distribute this workload somewhat. And also, while it's read-only only, that's still fine because there are way too many workloads that write their file once and they never modify it. And things like Hadoop don't even allow you to modify files. Then the phase two will, the benefit of this phase one is also that the actual replication happens kind of in background, and you don't use your compute node resources to write multiple copies of this data, which is also important because otherwise we all know how congested those networks are and how eager are people to actually do away with their extra I/O traffic so that there is more bandwidth and latency and less latency for their applications. Then the phase two eventually will allow us to do concurrent write updates to such files. But this will come with a penalty because we will need to wait for a commit and we will use more bandwidth for that. So potentially this would be like an optional feature. And then, I guess in the far future, the asynchronous file replication will allow us to also do concurrent updates without actually waiting for any of the commits, but it would require underlying features like what we are going to include in DOS to actually keep track of the consistency, and that's not going to be all that trivial. Small files on the MDT is another thing that we believe is important, so that you are able to reduce the overhead for access to those small files. Right now, those operations are way too important. You need to speak to multiple servers, obtain multiple logs on multiple targets, and so in general, it's quite slow. So the step one of this is to combine MDS and OSS into unified target code, which also allows us to drop quite a few bits of duplicated code, because all they really do is they accept RPCs, process them, and then send replies generically. So after this all is combined, the MDS will be perfectly capable of serving out data, and then we will add functionality to actually store this data on the MDT for certain small amount of data per inode. This will allow us to not only save on RPCs, but also the small files we would be able to store on MDT that has a much higher IOPS rate. So some performance boost will come from there as well. Eventually, you might even be able to build your file system on MDTs only without any OSTs if you don't expect to have any large files, or maybe even if you do expect to have large files, but you are fine with them residing on MDTs only. And that's it, I guess.